Your truck's engine is shutting down cylinders every time you drive, and you were told that's a feature. Manufacturers sold it as V8 power with 4-cylinder economy. What they did not mention is that your engine oil is now part of a high-pressure control system. Hidden lifters cycle thousands of times per trip, and one failure can scar a camshaft into a 4-figure repair. An entire aftermarket now exists to remove what was marketed as progress. The question is not whether a V8 can run on fewer cylinders. The real question is whether this system was built for 15 years of ownership or to pass a federal test cycle. Walk into any truck showroom from the late 2000s onward, and the pitch sounds almost too good to question. The sales banner promises V8 muscle when you want it, 4-cylinder efficiency when you do not. Brochures talk about seamless transitions, smart computers, and fuel savings that let you have your cake and eat it too. On the EPA sticker, a few extra miles per gallon are circled in bright green, just above a fine print note about active fuel management or dynamic fuel management. The salesman's line is simple. You will get all the power you expect from a big American truck, but with better mileage because the engine can shut down half its cylinders when cruising. It is progress, they say, and you will not even notice it happening. Underneath that pitch sits a different reality. The technology is not just a clever switch, it is a web of oil channels, pressure-actuated lifters, solenoids, and software logic that decides hundreds of times per minute how many cylinders your engine should actually use. The oil in your crankcase, once just a lubricant, is now a control fluid. Miss an oil change, use the wrong viscosity, or let a filter clog, and you are not just risking wear. You are risking lifter collapse, misfires, or even camshaft damage. The very thing that is supposed to save fuel can turn into a 4-figure repair bill, especially if you are out of warranty. Yet the advertising never mentions the added complexity. There is no asterisk on the miles per gallon claim warning you about hydraulic lifters that can stick or solenoids that can fail. There is no fine print about the risk of a stuck deactivation mode leaving you stranded or the cost of replacing a camshaft if metal shavings start circulating in your oil. The promise is always about savings, never about the cost if something goes wrong. Manufacturers, meanwhile, collect their fuel economy credits the moment the truck leaves the lot. The EPA test cycle is satisfied, the corporate average ticks up, and the truck counts as a win for emissions compliance. But the owner is left holding the bag if the system falters years down the road. Not every truck fails, but enough do that entire forums, shops, and aftermarket companies now exist just to disable or bypass the very system that was sold as progress. For the buyer who expects a truck to last 15 years, the real question is not whether the engine can run on fewer cylinders. It is whether that promise was made for the showroom or for the long haul. Receipts reveal what brochures leave out. In a quiet Midwestern kitchen, a 2012 Silverado owner sorts through oil-stained logs and a shop invoice. The diagnosis was an active fuel management lifter failure on cylinder 7, a misfire code P0307. The trouble began at 84,000 miles with a faint tick, then a check engine light, and finally a loss of power on the highway. The onboard diagnostic scanner returned codes P0300, P0307, and P0521. The mechanic found a collapsed lifter and a camshaft lobe worn smooth. The bill, $1,347.82, covered 8 new lifters, a camshaft, gaskets, and oil. Metal shavings turned up in the oil filter. The warning was clear. The owner's log showed oil changes every 6,000 miles, always with the recommended synthetic. The lifter's oil passage clogged anyway, and the software kept cycling the cylinder until the damage was done. In another state, a Ram 1500 Hemi owner hands over a different invoice. A multi-displacement system delete kit was installed for $2,180. His story started with a soft tick at idle, then a sudden misfire and a flashing check engine light. The shop scan showed P0304, cylinder 4 misfire, and a lifter that was stuck. After pulling the valve cover and finding a chewed-up camshaft lobe, the owner decided to remove the multi-displacement system altogether. The invoice lists new lifters that are not for the multi-displacement system, a standard camshaft, and a powertrain control module reflashed to lock out cylinder deactivation. The old lifters, pitted and blackened, sit in a bag under the counter. The parts cost nearly as much as a year's worth of fuel savings. The owner's regret. I bought this truck because I thought it would last. Instead, I'm paying to undo a feature I never asked for. Stories like these fill forms, scanned invoices, onboard diagnostics printouts, and teardown photos. Not every truck fails, but enough do that entire businesses now exist to disable these systems. For owners, the risk is spelled out in dollars and downtime. In 1981, Cadillac rolled out what it called the V8 6.4. The promise was bold, a luxury car with a big V8 that could magically turn into a 6 or even 4-cylinder at cruise, all to answer the pressure of rising fuel prices. National ads boasted about up to 20% better mileage, with no sacrifice in smoothness or power. Brochures showed diagrams of modulated displacement, and the showroom pitch was pure optimism. Technology delivering the best of both worlds, and Cadillac leading the way. But behind the wheel, reality caught up fast. The V8 6.4's brain was a primitive computer, barely able to keep up with real-world driving. Owners noticed rough transitions between cylinder modes, engines stalling at stoplights, and a persistent shudder that no amount of calibration could smooth out. The Eaton-developed solenoids and rocker arms were supposed to quietly deactivate valves, but instead they became a source of mechanical headaches. Reports of premature wear and unpredictable performance landed on dealer desks across the country. The press did not hold back. Automotive journalists called out the system's immature electronics and the mismatch between Cadillac's luxury reputation and the car's nervous behavior. By the end of the first year, the complaints had piled up. Cadillac quietly extended warranties and issued service bulletins instructing technicians to recalibrate the system and inspect the solenoids after just 5,000 miles. But the damage was done. By 1982, the V8 6.4 was gone, replaced by a conventional engine. No recall, just a silent retreat. 1 year was all it took for the first mass-market cylinder deactivation experiment to be shelved, leaving a trail of frustrated owners and a lesson about the risks of selling unproven technology as progress. By 2005, General Motors brought cylinder deactivation back from the dead. This revival wore a new badge, active fuel management. General Motors rolled it out on the 5.3-liter V8 engines in the Silverado and Tahoe, promising up to 12% better fuel economy when cruising. The pitch was familiar: V8 power when you want it, 4-cylinder thrift when you do not. But the real driver was not customer demand for high-tech engines. It was the pressure from tightening EPA and CAFE standards, which forced truck makers to squeeze out every possible mile per gallon or face steep fines. The solution was to engineer a system that could pass the test cycle, earn the company fuel economy credits, and keep the big V8 engines on sale. The marketing campaign was relentless. TV spots, glossy brochures, and showroom banners all claimed you could tow, haul, and commute with the same truck, all while using less gas. Underneath, though, the mechanical reality was anything but simple: a growing complexity under the hood. Active fuel management worked by using oil pressure to collapse special valve lifters, shutting off half the cylinders at light load. The process depended on a high-speed computer, a network of oil passages, solenoids, and lifters that had to work in perfect sync, thousands of times per minute. Oil was no longer just a lubricant, it became a hydraulic control fluid, and any slip in maintenance could throw the whole system out of balance. Fleet managers and private buyers alike were drawn in by the promise of lower operating costs. But the system's complexity meant that the old rules about oil changes and engine care no longer applied. Miss a service, use the wrong oil, or let sludge build up, and you are not just risking routine wear, you could be facing a lifter collapse or camshaft damage. Still, active fuel management became standard across General Motors' truck line, and soon competitors followed with their own versions. The technology was here to stay, not because owners demanded it, but because the regulations left little choice. For buyers, the question shifted. Was this new breed of truck built to last, or just to pass the next EPA test? A technician leans over a disassembled V8, finger tracing the lifter valley where modern fuel-saving tech hides in plain sight. Here, the lifter is no longer a passive part. It is a hydraulic valve, built to lock or collapse on command, its secret lying in oil, pressurized and routed through passages drilled into the block. When the PCM senses a light load, steady highway speed, and gentle throttle, it sends a high-voltage pulse to the valve lifter oil manifold solenoid. The solenoid snaps open, oil surges into the lifter's core, and in just 30 to 50 milliseconds, less than a blink, the plunger collapses and is locked by a tiny pin. The cam keeps spinning, but the valve stays closed. That cylinder goes silent. Multiply this by 4 or even more on newer systems, and the engine is constantly shifting between full power and fuel-saving mode, all without the driver noticing. Timing is everything. Oil pressure must rise and fall in perfect sync. Solenoids must react instantly. And the PCM juggles data from sensors, throttle, speed, load, even road grade before making each call. Oil too thick and the lifter will not collapse fast enough. Too thin and the lock might slip, causing a misfire. Sludge or varnish can block the tiny passages, starving the lifter of pressure. The relief valve guards against overpressure, but if it sticks, a lifter can stay collapsed even when the PCM calls for full power. The system can switch hundreds of times per minute, but every cycle depends on oil quality, solenoid health, and software logic. For the technician, a misfire or ticking noise means tracing PCM commands, solenoid response, oil flow, and lifter action. What was once a simple mechanical job is now a dance of hydraulics and electronics with hidden failure points. Oil is not just for lubrication, it is the lifeblood of the system. One missed oil change, one wrong filter, and the whole mechanism can grind to a halt. A faint tapping at idle, a sudden misfire, or a check engine light with a P0300 or P0307 code are often the first signs that something is wrong. Underneath the surface, a collapsed lifter or a scored camshaft may be at work, sending metal shavings through the oil and setting off a chain reaction. The culprit is a lifter designed to collapse for fuel savings, now stuck or starved for oil, unable to keep pace with daily demands. Repair shops see the pattern repeat. A Silverado or Ram arrives with a rough idle. The scan tool confirms the misfire, and soon the lifter valley is exposed on the bench. Sometimes a new lifter and hours of labor solve the problem. But if the camshaft lobe is worn, the repair escalates. Shop records reveal that about 1 in 8 lifter failures leads to camshaft damage, especially when oil changes are neglected or the wrong viscosity is used. Now the job means a new cam, a full set of lifters, and a flush to clear out metal debris. The bill can start at $1,200 for a single cylinder fix and climb past $3,000 for a full top-end rebuild. If metal shavings have traveled further, bearings and valve guides may also need replacement, pushing costs even higher. Even after repairs, the risk lingers. Every oil change becomes critical. Miss an interval, use a cheap filter, or let sludge build up, and the cycle can start again. Some owners install active fuel management or multi-displacement system delete kits, replacing lifters and reprogramming the computer, but these fixes often cost as much as the original repair. General Motors service bulletins estimate that 3% of active fuel management equipped trucks built from 2007 to 2014 required lifter or oil manifold repairs under warranty. Ram's Hemi multi-displacement system engines average nearly 2 lifter-related repairs per 10,000 miles in fleet data. The pattern is clear, clever engineering meets real-world risk, and the promise of fuel savings can vanish with a single breakdown. In 2013, the first real legal shockwave hit the industry, not from Detroit, but from Honda. Thousands of owners joined a class action lawsuit after their V6 engines, equipped with variable cylinder management, began burning oil and suffering premature camshaft wear. The lead plaintiff's attorney described engines that rattled at idle consumed quarts of oil between changes, and left families stranded long before the odometer reached six figures. Honda's official response was to settle. The company agreed to reimburse owners up to $1,500 for repairs tied to variable cylinder management failures, lifters, camshafts, and oil-related parts included. The settlement also forced Honda to extend the powertrain warranty on affected vehicles by 3 years or 36,000 miles, whichever came first, and to issue a technical service bulletin requiring synthetic 0W20 oil and stricter maintenance intervals. Most telling, Honda quietly redesigned the variable cylinder management rocker arm seals for the 2014 model year, aiming to slow oil leaks and reduce the risk of internal failure. On paper, it was a technical fix. In court, it was an admission that the promise of seamless fuel-saving technology could carry real costs for owners. One lawsuit did not change the market overnight, but it drew a line. When a smart feature fails in enough driveways, manufacturers can be held accountable not just for the fix, but for the engineering decisions that put owners at risk. Dynamic fuel management and Ram's multi-displacement system now cover millions of trucks on American roads. The latest GM engines with dynamic fuel management can pick from 17 cylinder patterns, switching up to 80 times per second, all orchestrated by software and a maze of oil passages. An SAE powertrain engineer calls it an algorithm with moving parts, where oil is not just for lubrication, but the lifeblood of a real-time control system. The result is a truck that constantly toggles between full power and economy, with every switch dependent on precise oil pressure, clean solenoids, and a computer's judgment. For many owners, that complexity is a deal breaker. The aftermarket has seized the opening. Shops now install delete kits that remove deactivation lifters, block off oil galleries, and reflash the computer to run in V8 mode permanently. A shop owner in Texas explains that most customers are not chasing more horsepower, they are trying to avoid a second lifter failure or a $3,000 camshaft job. Delete kits typically run $1,200 to $2,500, not far off the price of a full repair. The trade-off is clear. Keep the system and risk another failure, or pay up front to restore old-school reliability, knowing the factory warranty may be voided. For buyers who once trusted a truck to run for 200,000 miles, the rise of delete kits signals a growing skepticism. Was this technology really built for the long haul, or just to pass a test and move the metal off the lot? Start with the VIN. On any GM truck or SUV, the engine code, like LC9 or L84, reveals if cylinder deactivation is present. These systems rely on the right oil, precise software, and a spotless maintenance record. Demand proof of every oil change. Only synthetic oil such as 0W20 or Dexos 1 protects the lifters and camshaft. Miss a change or use the wrong filter and repairs can cost thousands. Run the VIN through recall, databases, and owner forms. Patterns emerge, and certain years and engines suffer more lifter failures. Scan for trouble codes. Look for P0300, P0307, and P0521 before buying used. A quiet engine is not always safe. Ticking often starts soft, then escalates. For current owners, never stretch oil intervals or stray from the manual. A fine mesh filter can catch metal shavings early. Some owners install AFM or DFM delete kits, but that voids factory coverage and may trigger emissions issues. In 2025, GM settled for $150 million after years of complaints about lifter collapse and oil consumption. GM extended warranties for some 5.3-liter V8 engines if maintenance could be proven. The real checklist is about knowing the engine's history and weighing the risk for a few extra miles per gallon. Today's trucks promise strength, but hide complexity beneath the hood, where oil isn't just a lubricant, it's a trigger for failure or savings. Not every engine fails, but enough do to turn a selling point into a gamble. Modest fuel savings can vanish with one big repair. The real question isn't about cylinders, it's whether these machines were built for your driveway or just the EPA spreadsheet. Let me know your thoughts below. If you're tired of products that fail before they should, subscribe. This channel is about exposing the design choices that made everything worse and finding what's still worth buying.